Let's start with the simplest possible architecture. We have clients sending requests to a single server. Everything goes into one place. And at first, this works perfectly. If you have 10 users, 100 users, the system is fast, simple, easy to manage. But here is the problem. This server becomes a bottleneck. All requests, all logic, all data goes through one machine. And even worse, this is a single point of failure. If this server goes down, the entire system becomes unavailable. It doesn't matter how good your code is, your application is offline. So naturally, we try to fix this. We add more servers. Now, instead of one, we have multiple servers handling requests. Sounds better, right? More servers, more capacity. But now we have a new problem. Who decides where the request goes? In this setup, the client is responsible. Client A goes to server 1. Client B goes to server 2. Client C goes to server 3. And this creates serious issues. First, the client now needs to know the system. It needs to know which server exists, which one is available, which one is overloaded. Second, no balancing. One server might be overloaded while another is idle. And third, if one server goes down, some users are completely broken. So yes, we solved one problem but created another. So how do real systems solve this? We introduce a new layer, a load balancer. Now, all clients send requests to a single point, the load balancer, and it decides where each request should go. Instead of client guessing, we centralize the logic. The load balancer distributes traffic across all available servers. For example, using round robin, request 1 goes to server 1, request 2 goes to server 2, and request 3 goes to server 3. Or even smarter, it can send requests to the least loaded server. But here is the most important part. What happens if a server goes down? Let's say server 2 is not working. The load balancer detects that and simply stops sending traffic to it. Requests are automatically routed to healthy servers. And from the user's perspective, nothing breaks. The application stays online, and this is the key idea. A load balancer is not just about performance, it's about reliability, it's about keeping your system alive. And this is the moment when your system becomes truly scalable. And this is just the beginning, because once you understand how to distribute traffic, the next question becomes even more interesting. How do you make your system faster without adding more servers? We will talk about that in the next video. If this helped you understand how real systems work, leave a like. It really helps the channel grow, and I will keep making these videos deeper and better. And subscribe if you want to learn how to think like an engineer, not just write code. Thanks for watching.